Hello, everybody. A warm welcome from Berlin. So this time we're going to continue on our noise reduction story, and it will be part 2. And I'd like to start with a short introduction. So my name is Fred Klein. I'm located in Berlin. And today we have Xavier from Rome and Zane here from London. And I'd like to hand over to Xavier. Do you like to say a few words about yourself?
Yes, thank you, Fred. So I'm Xavier Giannakopoulos. I'm based in Rome, Italy, and part of the automation, a specialist of automation. So I'm part of the SWAT team, following the Watson AIOps portfolio, Netcool, and other forms of automation that relates to ITSM.
Thank you. Zane, could you say a few words about yourself?
Yeah, hi, good morning. My name is Zane. I work in the Netcool development lab based out of London and worked with Netcool for many years. Yep.
Thank you. So let's go into business. What have we prepared today? So today we're going to continue the story. The continuation of the story will be Netcool Impact, and therefore we're going to cover what it is. So therefore we're going to talk about data source adapters. We're going to have a look into policies, what is a project, what is the maintenance window manager, and we're going to walk through one of those wizards which are included. And all of that will give you the overall capabilities of what you could achieve with Netcool Impact, why we have the solution in place. And I think the next slide we agreed that Xavier is going to talk you through. Please.
Absolutely. So to place a little bit this video in the context of the Watson AIOps family, it is good to remind that the family is made in successive layers, if you want. There is a first raw layer where individual collector get information from the environment which is being managed, watched, and acted upon. And it collects it then to pass this information to a series of IBM plasmid expression normalizer that will accept and clean those data under a series of perspectives. These perspectives are events and or alerts or metrics, topology, logs, and tickets incident. And of course, there might be more as we go on as the portfolio evolves. So out of these perspective, some of the structured one will come into tools like Event Manager, which is the topic of this video here. And the metrics will go into Metric Manager and the topology into Topology Manager. Which then, together with the non-structured data, this can be used and also complemented by the core AI manager part, and then put into the interfaces. Of course, Event Manager has its own interface, as you can see on the top right, and that we will use today. I think, Fred, that's with this introduction, I'm sure you can give some very good insight about how the Event Manager performs noise reduction.
Yeah, thank you very much, Xavier. And I think we covered it already in several videos. There's an overview and introduction video of what is the overall story. Then we have part 1, where we talked about all these capabilities of the Netcool pieces in there. So this is mainly around omnibus object servers, probe capabilities, and so on. And today we are going to take it a little bit further. So this capability of being able to take loads of events, this is a unique feature of Netcool. And we still have this feature in the Watson AIOps portfolio, of course. And the way it's done, it's using probes, rules files, probes adapters, which are there for general purpose, like log file collecting, SNMP trap collection, attaching to a core bus, these kind of things, or also very vendor specific. So if there is a special element manager you want to integrate, we do have probes for these element managers. And these probes know how to interact with these element manager. They talk the APIs or the export interfaces that are specifically exposed in these environments. Therefore, probes are available. Object servers, also something we have already covered in part 1. So this is the capability of correlating events, doing housekeeping correlations, doing positive, negative correlations, which is something we do within the generic clear correlation. And this is all covered in that video. And today we're talking more on impact and its capabilities and policies. Then we have the UI filtering capabilities. And last but not least, this will be part 3. This is all about the cloud native event analytics capabilities. So this is going to be scope-based grouping, this is seasonality, this is temporal correlation, topology correlation, super grouping, all these kind of nice things that we have within our AI capabilities of this solution piece. So part 1 is everything that we had in the box as Omnibus previously, which is now part of Event Manager. Part 2 is the impact piece, which is what we are talking about today. And part 3 is coming next. This is going to talk about these extra correlation capabilities that we've developed, firstly for Netcore Operations Insight, and which have been completely redesigned using Netcore Operations Insight version 1.6. So this is coming, and let's do part 2 today. And I think this architecture is something you want to talk us through, Xavier, isn't it?
Yes, thank you very much. So let's see how many fantastic pieces of NOI architecture we have installed today in order to come to you with this demonstration. At the core, there is the object server, which is duplicated to have a primary and a backup. And this is let's say, a core NOI installation, includes the object server, of course. On the lower part, Fred was so kind to use his own infrastructure to install what is called a probe. So this is also a probe installation. That's what has been done. And then configuration with the file, props, def, and rules. With a separate installation of netcool, there's also the piece on the lower right, NCO config, which is let's say, a X interface, which connects directly and needs an X connection also to the object server in order to easily and graphically determine all the configuration that are needed. On the upper part, you can see this green part offering the web UI. This has been done on IBM Red Hat OpenShift on the cloud. So this UI is based on Jazz, SM, and Dash, and provides an access to the event list, to the topology, to everything that, if you want, the user will be using through the web UI. Of course, taking the data from the object server itself. And now the special guest of today's presentation, Impact, which is another component of netcool that could be installed at the same time as the object server, or could be installed in a second time according to the kind of configuration that you have in mind. Then the demo data is some kind of external data that will be used by Impact in order to enrich in some of the scenario. And with that, you can obtain the same environment that you're going to see operate in the coming slides.
Thank you. Yeah, very good. So just to add to your explanations here is the upper part is what comes more or less out of the box from a cloud-based installation. And the lower part is typically what existing customers do have today. So they do have a on-premise installed netcool environment, which is typically installed on Linux, but can be also on Sun Solaris, on Power, on Z. So there are lots and lots of different environments. They're very, very distributed, so on many servers typically. And you could reuse all these existing environments and connect that to a freshly installed ROX-based environment by just using this setup. So that's the justification why we have chosen this kind of architecture for this video today. And the machine Batman down here, that's a simple laptop which is left to my desk, which I am using to create these kind of demo environments. So it has a netcool installation on itself as well. This is where the configuration tool resides. This is where my Simnet probe resides. And this is something we're going to use later in the demo when we do the enrichment. And the only piece on the ROX installation that is not out of the box is the extra demo data that I have added to the impact environment. Because what we do with impact is we use external data to enrich the data in the core object servers, because the main problem we have within these object servers is if we do get events from our underlying probe infrastructure, it is more or less exactly what the technology sends us. We do not add to that. So on the probe level, you can have an extra feature which is called lookup table. A lookup table is a static table where you can, well, let's say mostly replace IDs or numbers with meaningful text messages. That's the most common usage of these kind of lookup tables. But this is nothing that really helps you to determine, well, I do have, let's say, a link down message from a router. How important is that to me? Is there any customer impacted? Is there any service impacted? Who needs to know? By when do he needs to know? Or is this something that is just connected to a printer interface? And if this printer is running or not, is absolutely not mission critical. So I can really degrade the severity of this kind of severity critical event. So these kind of determinations you cannot do just based on the underlying and incoming probe data, because a link down interface is a link down interface, and they are all critical and red events by default. So when you have, let's say, 20 of these link down interface events at the same time coming into your system, where do you start? Let's say you just have one single operator, which is your subject matter expert, and he can't look into all of these events at the same time, and therefore it would be really handy to have a starting point, and that's exactly what we're doing. So we try to add data to make it easier to determine where to start the troubleshooting, which events to prioritize, and which events to use later on for resolution. And exactly this is what the role of impact is, and I have created this little chart to show you the various components of the impact solution. So in the middle, we do have the impact server. And the impact server is the core of that piece of solution. And impact usually comes as a cluster. So you have a primary cluster member, which does all the work. And you have secondary cluster members. The primary is by default the first in the list, which starts first, and then he claims to be the cluster master. And every other impact service, which are started later on, will be just cluster members. And you could do failover, failback within these clusters, but usually they are all equal, but just the master is the one who is in charge, and the one in charge distributes the workload to the other cluster members. This is how it's set up. So therefore, resilience, high availability is given because this is a cluster which is replicating the data within the servers itself. So it's built-in capability. And this is exactly how we do geo-redundancy and all these other capabilities as we do with object servers. So you could install them separately in geo-redundant environments. So data center A, maybe in Frankfurt, the other one may be located with Xavier in Rome. And you have a primary object server here in Frankfurt and a primary impact server here in Frankfurt, and a secondary object server and the secondary cluster impact member would be installed in Rome. And these components do know how to replicate the data between these two locations, and they are configured by default in a hot standby environment. So you don't have to care about replication, load balancing and all these kind of things, because this is built-in functionality in the tools. So this is the impact server. So if we look a little bit deeper under the hood of an impact server, it has several components in there. First, of course, he needs to know something has happened. And how do we notify the impact server about that something has happened? For that purpose, we do have two components. One is the event reader, which is here in the middle, and a little bit below is this event listener. Why do we have two of those? Well, One is listening to a source, that something happens and is pushed to the impact server. And the other component is actively listening. So for example, if you have a database trigger and this database triggers notifies that something happens on a database table, and this will send a signal to the impact server, and then this signal can be used to trigger a policy, and the policy knows the logic, and the logic defines what to do. So therefore, we have these triggers, which we call event sources, and the policies do contain the logic what to do. And within the policy, we define, for example, external data. External data, which is made available via these so-called data source adapters. So here on the right side, there's the third critical part of impact. These are the data sources. These data sources can be simple databases, or it can be a CORBA bus, or whatever. So there's quite a long list of data source adapters that we are having in the box. For example, we can read simple flat files, or we can send emails, for example. So this is also something we can do with impact. So these are the tools we do have available within Netcool Impact, and they all make together a very, very handy tool. And this is also acknowledged by our existing customers, because almost every single customer that has Omnibus installed is also using Impact because it's so handy. So I've heard customers say, this is a Swiss Army knife, and we can do magic with this kind of capabilities, because it is so important to link event data, that is outages, problems from coming directly from the technology, and you link that data with infrastructure data, or something like service data, or somebody who needs to know, or you write an escalation with that. So there are many, many, many use cases that you can perform with this general purpose engine. And we're going to look a little bit deeper in these capabilities during our demo.
Thanks, Fred. I must say, thanks for the explanation between event reader and event listener, which was a distinction that was not completely clear to me.
So far for the overall introduction, let's go into the demo. So this is the event piece within Event Manager. As you can see in here, events, we have loads of lovely events. And we are going to talk with the impact component. And to raise the user interface of Netcool Impact, you have to go here on the left side into the automations menu. And in here, you can go into Impact. Let's do that. So within Impact, we start with the data model. And the data model uses the data sources that we've shown previously to create these kind of modelings, so available databases, tables within the databases, and so on. And usually what we do within the data model is we show what kind of data is available. So for example, object server data. This is something where you would integrate a pointer towards your object server. So typically you have two object servers, a primary and a secondary, and they are usually configured in a failover component. Failback means that the data pointer also fails back to the primary when it comes online again. In here we have primary object server. This is the secondary object server, also called backup object server. With this little button, we can test the connectivity in here. So we are talking here on the ROX environment from our impact server to the primary and secondary object servers in here. And this opens a SQL connection as if we would do something, a read statement, a write statement towards the object server. There's also the possibility to encrypt all the pieces. By default, they are not. And with these little extra pointers, you can go into, for example, the impact database, loads of database tables in here. There are more pointers available out of the box to go towards almost anything that is available. Here's a pointer to a MySQL database, but you also could do Oracle and all the other data source adapters which are available in here. So this is how you construct your data model. This is something you would use later on within your policy to describe the data. So you need a handle which is pointing towards the external data, and that's exactly how you define this. So it could be a schedule, for example, internal or external data schedule. You could go into the service database, which is something that TBSM utilizes. Lots and lots of extra stuff which is available here. Going into the policies, this is a long list of available policies here in the impact server. And let's see if there's something we could do. So for example, this one, RBA events processing. This is a normal policy as you would expect. This is impact policy language, IPL. And you could also program in JavaScript. So there are these two languages available to construct this kind of logic. So this is where the policies all go. So you have data model. These are the pointers to your available data, for example, object servers, external data. Then you have the policies, which define the logic. And then you also have services. So services, for example, which triggers something. So for example, if you have a database trigger and you want to get notified in here, this is something. Or if you want to send an email, for example, this is where you would enter your SMTP host to send data to. And of course, all of this can have a separate lock. This can be encrypted. And as a service itself, it can be started and stopped. This is the default setting. All the green ones are started and all the red ones are stopped services. So of course, self-monitoring is one of these services. The policy logger, this is collecting all the various logs from the environment. This is the omnibus event reader, and there is the possibility to do operator views. Not much to see in here as we have not defined anything. So this is pretty much empty at the moment, and they can't show much in here. The maintenance window manager itself, this is a capability to do suppression out of the box. So a very simple way. For example, you have the first step to do is you need to define maintenance windows. So this can be a one-time window, this can be a reoccurring window, can be one of in weeks or month time, or nth day of the week in a month window. So several possibilities in here. I've created two samples. One is a maintenance window, which is scheduled every workday between 3 in the morning and 3:15, so a 15-minute window. And it has a time zone located in my time zone. It's in Berlin, and it's currently not active. This is what this little fellow shows you here. So if this would be something that would be active right now, then this would be a green one. We can make one. Let's go in here. Let's do one time. And of course, we want to do it. How about Rome? Do we have Rome in here? No, no Rome. Sorry. Will be Algier or Berlin again. Node equals Batman. This would be something that is in here that we are going to use. So we are creating with this a filter statement. Down here we have the timing. Let's say today from 5 o'clock, which is already past, until something later on. And this will be our one-time window. We're going to save it, and we're going back in here. Now we have a one-time window and it's active. So that means everything that falls under this filter will be suppressed at the moment. You could also have additional windows which may have already expired or future use. So this is what you could do in the maintenance window manager. This is just for simple out-of-the-box suppression of events. There's also a capability to do reporting, something like self-monitoring, these kind of things. Lots of reports that you can run. Profile report, for example, this is about efficiency, how many queries done, how long have they taken, these kind of things. All that can be done in here. You need to activate these, and you can stop these profile reportings by using this button in here. So that's the general overview of the components of what the Netcool user interface of Netcool Impact provides. And with the next step, I'd like to go into the provided sample. Now let's do the event enrichment. First of all, we need to define our data model. And the first step to define the data model is we need to point where our data is going to be residing. So this is what we call a data source. Well, we have all the possible options in the world. We could make a new database, and we could also use, for simplicity reason, one existing database. So let's choose the object server, because that is already a very fast and an available database. These are the connection credentials, and if we're going to make it from scratch, totally new, we need to go in here. So let's create a new data source adapter. And the data source adapter is in this type an object server. We could use almost any type of database that is available in here. So how are we going to name this? Giving it a name. Then we have only one single user configured with the password from the secret. This is by default max of 30 connections. It should not be 0. If you compare it with the original one in here, this has a failback scenario. This is the server name. So it's not installed on localhost, so we need to provide it here. And we can test the connection. Yeah, looks good. And let's copy the backup object server as well. Oh, no, we don't want to configure it on the backup object server. We're just using a data store in the primary object server. Yeah, why not? So let's do this. Failover, failab, disable backup. So this will kill the backup possibility in here. And this is now good to go. So now we have a pointer towards our object server, an additional pointer. And the next thing is we need to actually configure something within the object server that contains our data. So this will be the data type, so the table that we are reading from within the object server. And that is going to be here. So let's open an SSH connection, and in here we are going to use our configuration utility for the object server. It's really fast. And in here we're going to connect to the primary object server we set. We have the root password. Let's copy the root password we have remembered in here. Let's go into full screen, another full screen. Let's resize the tab a little bit. And here are now all the pieces of the object server. So visualization, the trigger system, the menus, the users. And we are now going into the databases of the object server. And the databases in here, this is the space where all our events are living. And we don't want to touch this. We want to touch something else which is not interrogating with anything else. So we have loads of databases already in here. And we have a general purpose place for extensions. This is the custom place. And in here, it's pretty easy to add another table. So these little buttons are used to manage databases. So we can create a new database. We can delete one of those. What we don't want to do, don't delete any default databases or tables. And here is a create table button. So let's create a table. this one will need a new name, and this little button is used to add columns. So first column is of course the key column, and we want to look into this table via a relationship. The node name within the event should be equal to the entry within our enrichment table. So therefore we define this as primary key, and it will be a varchar, let's say 128 characters. So this is our primary key field now. So let's have a few more of the fields. So we want to enrich on something like location, another varchar field. Let's say it will be 128 characters. We have more fields, something like service. This is also a free field, 128. Okay. We can specify as much as we want in here. For example, SLA, varchar 128. So it doesn't need to be final anyway. So this is now a new data structure that we have just defined. And if we press OK, then it will be created in the object server. Now you can see in here. So this is the name of the field, the data type we've just used. There's an additional field that we have not defined that comes out of the box. Row ID and row serial, these are default required columns that need to be in that table to make it a database table. And here's another tab in the user interface, which is very handy because in here we can now add demo data, which is what we want. So therefore we can choose what we want to provide. So of course we need a key field. I'm going to use my Simnet probe, so I'm very sure that I will have data from admin. Location is something like, I would say, I'm located in Berlin, and the service is something like master of disaster. So almost anything, it's demo data. SLA, something like 9 to 5, and within a week needs to respond to critical events within 15 minutes. So if somebody needs to respond to critical events, maybe we want to know about a specific application, an email address, these kind of things. So let's add this as well. So let's go back into the column definitions. So now we have here a data entry. Go back to the definitions and let's add, for example, response email address. Oops, that was a little bit quick because I made it an integer, and an integer is nothing we want to do. Edit column, so therefore you can see you can't change it to varchar, so therefore we need to drop this additional column, and we can do it here. Kill, yes. Changed. And if you compare back to the data, it's still there. So it takes all these changes. So this is very transparent and very responsive in here. So we can do on the fly all these different changes to our data model in here. Response, email, and this time we do it correct. Varchar 256, make a little bit more space. So let's add the application column in here. Let's make it a little bit more lengthy, 256, like the email address. So we can add data on the fly. We can add columns in here. And as you can see in here, My original data record is still here. So I've added a few more records in here, and this might look like this. So just a few demo data samples to enrich our existing events from the Simlet Pro. Going back to impact. So the next step we need to do after we have defined our data pointer, we need to save it in here. Then we need to add a table in here. We have now the demo data pointer in here, and we want to add a data type. And the data type is located in the object server. Now we can see we have done it correctly. We have access. We have found our fields. It's really cool. We can make this key field. And we have a key field in here. And this is pretty cool. So we could add in here additional filtering, sort order, whatever. We could link this table to other stuff. So for example, if you have a more complex data model, caching is something that is useful if you do not want to hit your source data each and every time. As we are now in development mode, I suggest to not use caching at all. Later on, when you have defined your policy and the data model, then it's fine to enable this caching. If you use caching, then you create a local temporary data store in here, which is then used for holding back the data within the impact server, so you do not hit each and every time your source. For development purposes, if you change a lot of stuff, this is not really useful, so therefore just use it later on when you're very sure about what you've done. So let's save all this. And now we have a data model. And the next thing we need to do is we need to go into our wizard. And the wizard is hiding here. So within policies, we can use the wizard. So this is impact policy language. This is JavaScript policy. These are the two types you could choose. And this is the wizard collection. So we have a few of those to create out of the box, easy to use policies. And today I would like to show how event enrichment is used. And we go into demo Simnet, and we want to use one of these omnibus event readers. Yes, of course, there are more, but omnibus event reader is fine. And now here comes a tricky piece. We don't want to read everything. We want to read something where we need to act on. So therefore, we want to restrict our events to Simlet probe. So this is class equals 3300. And of course, we want to reduce it to something that we haven't seen so far. So for example, if the location field is empty. If we have already updated this, then we don't need to do anything in here. So this is, we want to do event enrichment, and we don't want to do it over and over again, just once. Now, the node field is something we have already matched. That is the incoming field. We want to use location field. We have a service, not sure about service, response email, application. This is something we do not have as extra fields at the moment in the event. So we just concentrate on location and service as the enrichment pieces. Next, we do finish, and we are done. So now here's our enrichment policy. So the wizard has built this policy. We do have a few statements in here. Let's separate this a little bit. The first one is a comment, this one. Then we have a log statement. This will go into the policy logger if the policy logger is activated, and we get a pointer construct. which is enrichment org nodes. So this holds the outcome of this statement. And this statement is a match into our demo data pointer within the object server database that we've just created. And we are going to compare the value in the node field, which is the key field, with the node field from the event. So the event container, that's a construct which contains all the data that is coming from the triggering event. So that is in a container, and that's described in here. So I've tidied this up a little bit. The next construct we have in here, this is counting the results which are coming from the object server. So how many events, so many records have we covered in here? Are there any? This is another log statement that is going here. And this is now a condition. If we have found something in the object server, yes, we have found something, num greater 0, then we want to copy the new stuff to the event construct that we have. And with that statement, we are simply updating the triggering event that has triggered the whole policy. So remember, and the last statement is again a log statement. So where is the activation of my policy now gone? So if we look into the Omnibus event reader, by double-clicking on it, read, done. Then we have something new in the event mapping. We have a new statement in here. So this is the statement we have defined during the event enrichment wizard, and it is already active, and it's all the events which do fulfill this filter statement are then thrown against this demo simulate policy, which we've just constructed, and are run through this policy. So this is actually already working. If we want to deactivate it, we can set active to no, or we could deactivate the event reader completely. So let's go back to the event list. So back in the event list, so you can see here on the left side all the entries for the node field. Tally is how many of those events have you received, last occurrence, when has it occurred last time, summary field. All this is coming, summary is coming directly from the Simulate Pro. Last occurrence is something that our housekeeping triggers have created in the object server. And here, customer, location, and service fields, these are the results of the impact policy. So how is that helping us now? So this is now data that is not coming from the technology. So this link down message, this one, is now enriched with a customer, location, possibly a service. And with that kind of additional information, you are now in a position to make a decision which link down is more important. So there's a customer, there's contacts, there's service, and this is just a sample. So think of, you enrich more of this data. You could possibly traverse a service tree, incorporate redundancies, these kind of things. So for example, if you do have multiple link downs from systems which are then front-ended by a load balancer, and only 10% of my existing providers have been impacted and 90% of the providers are still working up and good, then the overall service is still good and running unless it's maxed out. But that gives you the kind of insight to really deep dive into the troubleshooting process, really think about where do I need to start based on all these events. And this is what we do with advanced correlations as well as with event enrichment. This is the story. Here's another best practice. If you are going a little bit deeper into policy creation, logic, state machines, and these kind of things, then you may want to draw upfront what you want to create. So what is the available data on, for example, where are my triggers? What kind of data can I use externally? How is it linked? What kind of data is available in an event? How do I relate the data between the various sources? What kind of states do I want to go through? And all this can go into this kind of diagram. And this kind of diagram helps you dramatically speeding up the development process, because in here you define in a graphical way what you want to achieve. And you can discuss this within your group. And the actual coding within Impact is relatively small. So this is coming from Zane. He was very kind to hand this sample over. He told me that just implementing this logic took him a day, finally. So once all the logic was defined and talked through and discussed, then the implementation process is really quick. And this is how you work on these kind of enrichment and correlation processes in production. So typically you want to have some kind of project management on top of that, because if you're interfacing with many parties, then you don't want to mess up, and you obviously don't want to go back and forward all the time during your implementation, or be surprised, oh, I missed that flag and I need to implement that firsthand. And that is with the other group and these kind of issues. So therefore, due planning is really saving a lot of time, and this is how to do it. So this is from our team, the best practices that we want to share. And with that, let's summarize it. Now you've seen how event enrichment works. We have done it using the event enrichment wizard. There are more wizards available. And that's everything I wanted to show today. Xavier, do you have any more questions on this?
Oh, I think it's great. I mean, it's a vast topic, but I think you've expressed all the main places where you can look for information. So I think that's a good day of instruction.
Yeah, and you really learn this tool by exploring it and starting simple things like using the wizards, and by deploying these and reading the manuals or going to the courses, then you get the ideas of all these bits and pieces do work together. As I told you in the beginning, this is a very popular tool. So almost every of our customers do use Impact, because it's so handy, so quite easy to use once you get a handle into it. And with that, I'd like to say thank you for your attention. Let's switch back to the presentation mode. I have a nice thank you slide in here. So thank you very much for your attention. And with that, I'd like to close today's call. And if you do want to see something else, please drop us a note. We are always open to suggestions. If there's a topic you want to see covered by the SWAT Explains video series, just let us know.